Electricity. This is the chapter of our discussion for today. Electricity is very relevant term. You are very much familiar with this, and you can't imagine the current existing luxurious life in the absence of electricity, right? We need the electric support for doing all our daily activities. We can't imagine. It's not only helping in the medicinal field or in the other particular field. No, it is associated with the human life. So the electricity is a greater discovery of humankind. And what is this electricity? Very simple. It's something which is being produced from a simple lab experiment. Imagine, you can't, it's a very amazing fact that from a laboratory experiment in a simple scale manner which was identified, from where it has now come to this existing level. Electricity, the term, how you may be related with this is very simple. That is, you will switch on the switch. As you switch it on, you will find the bulb glowing, the fan running, or your mixie it's rotating, or some other things. But you are not at all aware of the things what is happening behind it. Or as you may switch it on, immediately the bulb glows. Something happening in between the switch and the bulb, and that something is nothing, the flow of electric current. Something is flowing from one end to other end that helps in the purpose of glowing, and that flow, that is what we say as current flow. Something is flowing means the flow current. Current is actually the term itself meaning flow. So current means something flowing. It's not current is flowing. Current means something flowing. That something is nothing, the flow of charges. So I can make a conclusion that electricity is nothing. It is the flow of charges through a conducting wire responsible for the current. And so from this I can make a definition that current is nothing. It is the rate of flow of charges, or it is the amount of charges flowing through a unit area in a unit of time. So with the help of a mathematical formula, I can represent this, introduce. Say, if I is the formula, symbolic representation of current, and if Q is the symbolic representation of charge, then I is nothing, Q by T. This is the formula relation where current I is nothing, it is the amount of charges Q flowing in a unit area in a particular unit time, say T. And the unit in which these terms are actually measured as current is measured in units of ampere, represented by the letter capital A, which is nothing, equivalent to the abbreviation like this, named after the scientist who discovered it. And see, while writing in the expanded form, you should use only the small letter A, but symbolic capital A, since it is named after the scientist. 1 ampere is nothing. Unit of charge is coulomb. 1 coulomb of charge represented with the symbol C, or its expansion come like this. 1 coulomb of charge flowing in 1 second. So 1 ampere is nothing, is defined as 1 coulomb of charge flowing in 1 second, or amount of current. Current is nothing, it is amount of charge flowing per unit area in a unit interval of time. And 1 coulomb of charge is actually a very big unit of a particular charge. Here actually, though I say the term as charge, it is not simply, that is commonly, you can't stick on with the term generally charged, but very precisely they are electrons. The negative charged particles, negatively charged particles known as electrons are actually flowing through the wires which are responsible for the current flow, that is electricity. So 1 coulomb of charge includes how many electrons? See, 6 into 10 raised to 18 electrons makes 1 coulomb of charge. where the charge of one electron is equals to 1.6 into 10 raised to minus 19 coulomb. A single electron has got only this much amount of charge, whereas this much number of electron makes 1 coulomb of charge. So 1 coulomb is actually a very bigger unit of charge. So that's why we go for the smaller units like a millicoulomb, fermicoulomb, like that, and which comes in the order of 10 raised to minus 3, etc. So these are the some terms associated with the definition of current. So let's continue the discussion with the knowledge how electric circuit is made and what is the need of it. That is, a simple electric circuit will give you a beautiful pictorial representation of the electricity function. So electric circuit is nothing. It demands the presence of few electric components to make providing the path for the flow of electrons. For that, this is a symbolic representation of a cell. That is, the longer line represents the positive terminal, shorter line represents the negative terminal, and the combination of cells makes the battery. So I got now 3 cells making the battery, connecting with the connected wires. Then I just extend the wires. I connect it with a switch. Now the switch is open. If I put a point in the middle, it represents the closed switch circuit. And then this is my bulb. So this is a very simple electric circuit including a battery, bulb, connecting wires and an open switch. So once I put the key, what is going to happen is the circuit is becoming complete. That is, the wire which starts from here, it gets closed to here. There is no any break in the path of the electrons to flow. So what is expected here? Actually, you know well, this is what we are doing. I am putting on the switch means I am closing the circuit and I am helping the charges to move through the wires. Once the charges move through the wire, the bulb is expected to glow like this. And what is the need of this battery? Simply hold a wire, conducting wire, and connect it with a bulb. Do you expect it to glow? No. So it needs the support. That is, though the wire includes the electrons within them, they are not able to move. They are remaining stationary in the conducting wires. So it demands some external agency to provide energy to these stationary electrons so that they can move freely through the wire, and that is done with the help of this battery. That is, the battery, the positive terminal attracts the electrons, negative terminal will push the electrons. Since electrons are negatively charged particles, so the electrons are expected to flow in this direction through the circuit. So electron is moving in this direction from the negative terminal to the positive terminal, and since there is if there is any break in the path, the bulb will not glow, because the electrons should reach, start from here, should reach here, then only the circuit will become complete. And here in this case, another important thing, never expect that is the electron starting from here, only after reaching here the current will flow through the wire. No. Once you close the thing, the immediate electron here will reach here, the one here it gets pushed up. That is enough. That's why immediately if you put on the switch, the bulb glows immediately. It does not require from the switch the electron to reach the bulb. It does not require that much time. It's taking place so rapidly so that as you put on the switch, the circuit is becoming completely closed, helping the flow of charges, making the electricity supply through the circuit. And this is a simple electric circuit. Another important thing associated with this is that the direction of current flow. Though I told you electrons are moving in the direction from negative terminal to the positive terminal, the direction of current is, that is I, is expected to flow in the opposite direction. This is the direction of current. I is flowing from positive terminal to the negative terminal. This is the conventional method of, because when the discovery was made, when the study was made associated with this electrons and all, if they were not aware of the negative charges, they believed that the positive charges were actually responsible for the contribution of electricity. So, positive charge, if electrons are moving in this direction, of course, the positive charges are moving in the opposite direction. That is, this positive terminal will push the positive charges and it is getting attracted by the negative charges. So, conventional method believed that positive charges were responsible. So, that itself has been still, though the later discoveries made a identification, it's not positive charges but the negative charges are responsible for it, but still the conventional current direction is strictly followed, that is, current I is expected to flow from positive terminal to the negative terminal. And what is the reason for the negative charges electrons has been treated? Then I can relate with the atom model. You know that all matters are made of atom, and the atoms includes nucleus, electrons revolving around it. Where within the nucleus you got the positive charge, where the negative charges are moving around the nucleus. So a little energy is enough for these moving electrons to detach themselves and to become free, whereas more energy is demanded to remove or detach the positive charges from the nucleus. That's why the negative charges are expected to move freely, but not the positive charges. And this is the history behind it. And the knowledge what we require is conventional current direction flow. I is always positive to negative terminal, and electricity is expected to be flowing only through the complete conducting circuit path. So electric potential and the potential difference, that is the next topic of discussion. That is, I have told you just before that while constructing a circuit diagram, we need the presence of a cell. What is the role of the cell? It is providing something. It is providing helping the electrons to carry out the movement. But let's compare it with the case of another situation. You know that water can flow only from a greater height to a lower height. If it is a flat surface, it remains stagnant. But if you make the water to move, that is, you can expect the water to flow only if there is a height difference existing between them. The same thing is done here. That is, the electrons can flow only if there exists a potential difference, and that potential difference is provided by to the circuit. It is done with the help of the cell, or in case of our house domestic electric circuits, the power supply, that is from the power stations, we receive that potential difference which is distributed to the different circuits. So this is what known as potential difference. Potential difference is nothing. It is the condition made available to the electrons so that they can move freely from one end to the other end. So what could be the definition of it? So here potential difference is nothing. It is the amount of work done to move a unit charge from one point to the another point. The amount of work and how much work you do with respect to a unit charge to move it from one point to another point is what known as potential difference existing between the point. So if I use the notation V for the electric potential, which is symbolic representation V, of course it is measured in units of volt, V itself. So V is nothing. It is the amount of work done per unit charge, W by Q, to move it from one point to other point. So here it utilizes its chemical energy to provide the potential difference so that the electrons can experience that potential difference so that they can carry out the movement from one end to the other end. So what volt of supply, that is what potential is supplied to the circuit, it is nothing, work done per unit Q. That is, each Q charges to move from one point to other point, how much work is being done by them. That is equivalent to the potential difference or electric potential. Or in another way, you can say that electric potential is nothing. It is defined as the amount of work done to move a charge from infinity to that a particular point. For time's sake, we need only this definition, where in terms of its unit, I can say 1 volt is equals to 1 joule of energy done for 1 coulomb of charge. So 1 volt is nothing. It is defined as 1 joule of energy done to move a 1 coulomb of charge from one point to the another point. So this is what known as electric potential and the potential difference. So what is an electric circuit? We already learned it. Right from the lower class we have already learned it. But something new. That is, we need the circuit diagram representation to represent all the phenomena associated with electricity. So in addition to the basic knowledge, we need to add a few more new terms. So I'll introduce everything together. Very beginning, cell. And the combination of cells, battery. Open switch, close switch. Joint wire. Simple continuous line represents the wire. So if I show a diagram like this and a dot, it means that the wire has been jointed here with this wire. Whereas if I draw like this, wire crossing without touching. Okay, this is without overlapping, it crosses the wire without touching it, interrupting it. Then I'll just introduce it, later I'll tell you what it is. Resistance. The resistance of the wire is represented with a symbol like this. Whereas a variable resistance, like this, it should be drawn either like this or like this, is what known as rheostat or variable resistance. For time's sake, just remember these diagrams. Later I'll introduce the use of it or the role of these things. Then comes if you draw like this represents a meter. A meter is nothing. It is a device used to measure the amount of current. See, in the previous case I told you I is amount of current, and this I you can read in amperes using the device ammeter. Another important thing is that ammeter should be connected only in series to the circuit. That is, wherever you include the circuit, it should come in line with the components in series. I highlighted in here itself. Always connected in series in the electric circuit, whereas voltmeter as a term name sounds, it is nothing. It is a device used to measure the voltage or the electric potential. How much potential difference? You might have seen in the batteries and all, 1.5 volt, 2.3 volt, like that. Or in the domestic electric circuit, we got 220 volt supply, and that volt, that could be measured with the help of a voltmeter. That is the device meant for it, and that device always should be connected in parallel in the circuit. Then only you can expect the proper measurement of the physical quantity. I highlight here, it should be connected always in parallel, whereas ammeter in series. So these are the different symbolic representations involved in the construction of circuit diagram.